Among the vast expanse of universe, there's a small watery planet housing billions of humans, and therefore societies that wage war, make peace, and interact and depend on their environment. Today we'll focus on a man named Albert Einstein, who developed an idea, E equals mc squared, which had extreme significance to the world. Albert Einstein was born in 1879 in Germany and is a world-renowned scientist for his contributions to physics. Although born in Germany, he moved to Switzerland in 1896 to attend the Swiss Federal Institute of Technology. There, Einstein studied electromagnetic theory and philosophy, both of which helped him in his future contributions to physics. Einstein used philosophical thinking to figure out logically and test his ideas about physics, which he supported with many of his famous thought experiments. After his studies in college, he worked in the Swiss Patent Office, where he registered and examined electronic devices for the government. Despite criticism and mockery from his peers, in this humble upbringing as a patent clerk, he developed his general theory of relativity, which challenged some of the most basic concepts from classic Newtonian physics. In 1932, Einstein moved to the United States under a growing threat from Nazism, where he lived until his death in 1955.
In the equation E equals mc squared, the E stands for energy, measured in joules. The m stands for mass, measured in kilograms, and the c stands for the speed of light, measured in meters per second.
E equals mc squared is known as Einstein's general theory of relativity, and deals with mass and energy equivalents for objects at rest. For objects that are in motion, Einstein developed another theory called the special theory of relativity. This theory deals with objects that are in motion and how they are affected by gravity.
It really is amazing. The paper that he wrote in September of 1905 developed the basic idea of E equals mc squared, except it was more m equals E over c squared. Same equation, but he argued in this paper that when an object emits light, say a flashlight, it becomes lighter, that the decrease in mass would be equal to the amount of energy radiated divided by the square of the speed of light.
This equation shows that mass and energy are interchangeable and can be converted from one form to another. But what this really implies is that mass and energy are two forms of the same thing. Tiny amounts of mass can contain massive amounts of energy, and anything with a certain amount of energy can have a tiny amount of mass. On the Sun, hydrogen atoms are combined through nuclear fusion to create helium atoms. The joining together of these lightweight elements releases massive amounts of energy. Conversely, tiny objects that have mass when at rest contain massive amounts of energy even when they aren't moving. So this equation shows that with just a tiny bit of mass, the energy it contains is astronomical, because its mass must be multiplied by the speed of light squared to get the energy. So what Einstein's equation is really saying is energy equals mass times the speed of light squared.
Indeed, the development of the nuclear bomb was a devastating result of my work, but as long as there is man, there will be war. As mankind develops, the technology with which he uses to destroy himself will advance. I know not with what weapons World War III will be fought, but I know World War IV will be fought with sticks and stones.
Einstein's equation E equals mc squared was so powerful in its simplicity, but there were some complicated historical side effects of his theory. Einstein had a major role to play in the development of nuclear weapons, and in his later years, he said that he regretted ever thinking up his theory in the first place. What you really have to ask yourself is, Can an equation be too powerful?